Hi! In this video we will discuss basic feature generation approaches for datetime and coordinate features. They both differ significantly from numeric and categorical features. Because we can interpret the meaning of datetime and coordinates, we can come up with specific ideas about feature generation, which we will discuss here. Now, let's start with datetime. Datetime is quite interesting feature because it isn't only linear in nature, it also has several different periods like year, day or week. Most new features generated from datetime can be divided into two categories. The first one, time moments in a period, and the second one, time passed since particular event. First one is very simple. We can add features like second, minute, hour, day in a week, in a month, or in a year, and so on and so forth. This is useful to capture repetitive patterns in the data. If we know about some non-common periods which influence the data, we can add them as well. For example, if we are to predict efficiency of medication, but patients receive pills one time every 3 days, we can consider this as a special time period. Okay, now, time since particular event. This event can be either row-independent or row-dependent. In the first case, we just calculate time passed from one general moment for all data, for example, from year 2000. Here, all samples will be comparable between each other on one time scale. As the second variant of time since particular event, that date will depend on the sample we are calculating this for. For example, if we are to predict sales in a shop, like in the Rossmann store sales competition, we can add the number of days passed since the last holiday, weekend, or since the last sales campaign. Or maybe the number of days left to these events. So, after adding these features, our data frame can look like this. Date is obviously a date, and sales are the target of this task, while other columns are generated features. Weekday feature indicates which day in the week is this. Day number since year 2014 indicates how many days have passed since January 1st, 2014. Is holiday is a binary feature indicating whether this day is a holiday, and day still holidays indicates how many days are left before the closest holiday. Sometimes we have several datetime columns in our data. The most straightforward idea here is to subtract one feature from another, or perhaps subtract generated features, like ones we just have discussed. Time moment inside a period, or time passed in the row-dependent events. One simple example of such generation can be found in churn prediction task. Basically, churn prediction is about estimating the likelihood that customers will churn. We may receive a valuable feature here by subtracting user registration date from the date of some action of his, like purchasing a product or calling to the customer service. We can see how this works on this data frame. For every user we know last purchase date and last call date. Here we add the difference between them as new feature named dateDiff. For clarity, let's take a look at this figure. For every user we have his last purchase date and his last call date. Thus, we can add dateDiff feature, which indicates number of days between these events. Note that after generation features from datetime, you usually will get either numeric features, like time passed since year 2000, or categorical features, like day of week. And these features, now, are need to be treated accordingly, with necessary pre-processings we have discussed earlier. Now, having discussed feature generation for datetime, let's move on to feature generation for coordinates. Let's imagine that we are trying to estimate the real estate price, like in the Deloitte competition named Western Australia Rental Prices, or in the Sberbank Russian Housing Market competition. Generally, you can calculate distances to important points on the map. See this wonderful map. If you have additional data with infrastructural buildings, you can add as a feature distance to the nearest shop, to the second by distance hospital, to the best school in the neighborhood, and so on. If you do not have such data, you can extract interesting points on a map from your trained test data. For example, you can divide your map to squares with a grid, and within each square find the most expensive flat, and for every other object in this square, add the distance to that flat. Or you can organize your data points into clusters, and then use centers of clusters as such important points. Or again, another way, you can find some special areas, like the area with very old buildings, and add distance to this one. Another major approach to use coordinates is to calculate aggregated statistics for objects surrounding area. This can include number of flats around this particular point, which can then be interpreted as area's popularity. Or we can add mean realty price, which will indicate how expensive area around selected point is. Both distances and aggregated statistics are often useful in tasks with coordinates. One more trick you need to know about coordinates, that if you train decision trees on them, you can add slightly rotated coordinates as new features, and this will help a model make more precise selections on a map. It can be hard to know what exact rotation we should make, so we may want to add all rotations to 45 or 22.5 degrees. Let's look at the next example with realty price prediction. Here the street is dividing area in two parts: the high price district above the street and the low price district below it. If street is slightly rotated, trees will try to make a lot of splits here. But if we will add new coordinates in which these two districts can be divided by a single split, this will hugely facilitate tree building process. Great! We just summarized most frequent methods used for feature generation from datetime and coordinates. For datetime these are applying periodicity, calculating time passed since particular event, and adding differences between two datetime features. For coordinates, we should recall extracting interesting samples from trained test data, using places from additional data, calculating distances to centers of clusters, and adding aggregated statistics for surrounding area. Knowing how to effectively handle datetime and coordinates, as well as numeric and categorical features, will provide you a reliable way to improve your score and will help you devise that specific part of solution, which is often required to beat very top scores.